North Africa, late summer, 1942. The sun hung merciless over the Libyan desert, turning metal surfaces into instruments of torture and reducing visibility to a shimmering haze where earth and sky blurred into undifferentiated whiteness. In a makeshift workshop constructed from salvaged canvas and scavenged materials just outside Tobruk, a team of German mechanical engineers gathered around an object that would fundamentally alter their understanding of the war they were fighting. The object was unremarkable at first glance, almost disappointingly ordinary. A small, boxy vehicle painted in dull olive drab, its body coated with the fine talcum powder of desert dust, its tires worn but intact. One of Field Marshal Erwin Rommel's reconnaissance units had captured it 3 days earlier after a brief skirmish with an American patrol. The vehicle bore white stenciled markings on its hood, registration numbers that meant nothing to the German soldiers who had driven it back to their lines. It was a Willys MB, though the Germans knew it simply by the name that American soldiers called it, a Jeep. Just another piece of captured enemy equipment, or so they had initially assumed. Hauptmann Friedrich Weber, a mechanical engineer who had designed automotive components for Daimler-Benz before the war, approached the vehicle with the clinical detachment of a surgeon preparing to perform an autopsy. He had examined captured British trucks, studied knocked-out Soviet tanks, analyzed the remains of American aircraft that had crashed in the desert. This was routine work, part of the intelligence gathering that kept German forces informed about enemy capabilities. But Weber possessed an instinct honed by 2 decades of engineering experience, and something about this particular vehicle troubled him even before he began his examination. It was too clean in its design, too purposeful in its construction. There was an aesthetic quality to its simplicity that suggested not primitive manufacturing, but rather sophisticated reduction, the kind of elegant engineering that emerges only after countless iterations and refinements. Weber's team consisted of 6 men, each selected for their expertise in different aspects of mechanical engineering. There was Lieutenant Hans Richter, a specialist in engines and powertrains who had worked at BMW's aircraft engine division. Feldwebel Otto Kraus brought expertise in metallurgy and materials science. His peacetime career spent analyzing metal fatigue in railroad components. 3 junior mechanics, each trained at technical schools in Stuttgart and Munich, rounded out the team. They brought with them the tools of their trade, precision instruments salvaged from workshops in Berlin and Dusseldorf, micrometers and calipers and testing equipment that seemed absurdly sophisticated for the brutal simplicity of desert warfare. But Rommel understood the value of intelligence, and he had specifically requested this analysis. The field marshal had seen these vehicles operating in combat, had watched them navigate terrain that immobilized German trucks, had observed their ubiquity across American formations. He wanted to know what made them possible, and more importantly, he wanted to know what their presence revealed about American industrial capacity. The initial examination began with documentation. Every component was photographed, measured, catalogued. The Jeep measured 132 inches from bumper to bumper, just over 11 feet of vehicle that somehow managed to transport 4 soldiers and their equipment across terrain that would defeat vehicles twice its size. Its width spanned 80 inches, narrow enough to navigate trails designed for nothing more substantial than pack animals. Ground clearance measured 8 3/4 inches, providing surprising obstacle crossing capability. The vehicle's curb weight registered at 2,215 pounds, remarkably light for something expected to carry combat loads exceeding half a ton across hostile terrain. These measurements themselves told a story, spoke of careful calculation and deliberate design choices. This was not a vehicle that had evolved haphazardly. Someone had established precise requirements and then engineered a solution that met those requirements with minimal excess. But measurements were merely prelude. The real investigation began when Weber's team started disassembly. They began with the body, removing the flat metal panels that formed the vehicle's exterior. The body was constructed from stamped steel panels, each one formed in massive presses that shaped flat metal sheets into complex 3-dimensional forms in a single operation. Weber ran his hands over these panels, feeling for the telltale signs of manufacturing quality. The metal thickness remained consistent throughout, no thin spots or stress concentrations. The stampings were clean, precise, with tight radii and well-defined features. Each panel bore tooling marks that indicated sophisticated die design. This level of precision stamping required not just good equipment but exceptional tooling, dies that cost thousands of marks to produce, and could only be economically justified if production volumes reached into the tens of thousands, possibly hundreds of thousands. Richter focused his attention on the engine, that critical heart of any military vehicle. He removed the hood, a simple panel that lifted away to reveal the power plant beneath. The engine was a four-cylinder inline unit displacing 134 cubic inches, or 2.2 litres in the metric system that Richter thought in instinctively. It was a side-valve design, old-fashioned even by the standards of 1942, the kind of engine architecture that American manufacturers had been building for decades. Automotive purists might have sneered at its primitive layout, but Richter immediately recognized the genius in this choice. Side-valve engines were simple, robust, tolerant of poor fuel quality and irregular maintenance. They produced their power at low revolutions, generating substantial torque for vehicle propulsion without requiring high-precision manufacturing or tight tolerances. This engine could be built quickly, repaired easily, and would continue functioning under conditions that would destroy more sophisticated designs. But the revelation came when Richter began measuring the engine's components with precision instruments. The tolerances were extraordinary. The cylinder bore measured exactly 3.125 inches across, with variations of less than 0.02 of an inch from one cylinder to the next. The crankshaft ran true to within tolerances that Richter associated with aircraft engine manufacturing, not mass-produced automotive units. He removed the oil pan and examined the internal components, finding bearing surfaces that showed evidence of precision grinding, connecting rods that had been carefully balanced, a level of manufacturing quality that seemed absurd for a vehicle that American soldiers apparently treated as disposable equipment. German military trucks were built to similar specifications, certainly. But those were specialized military vehicles produced in limited quantities by firms like Opel and Daimler-Benz, each one representing significant manufacturing investment. The crankcase itself provided another revelation. Richter had expected to find a simple iron casting, rough and utilitarian. Instead, the casting showed evidence of careful pattern work and quality control. The metal was dense, free of porosity or inclusions. The mating surfaces were precisely machined, flat within 1/1000th of an inch across their entire area. These weren't approximate specifications. These were precision engineering standards, the kind typically reserved for aircraft components or high-performance racing engines. Yet this engine came from a vehicle that American doctrine classified as expendable field equipment, something to be used until it broke and then abandoned for a replacement. The disconnect between the visible quality and the apparent tactical role of the vehicle created a cognitive dissonance that troubled Richter deeply. Krause turned his attention to the vehicle's frame and suspension, the structural elements that tied everything together. The frame consisted of two parallel steel channels, each one precisely formed and then welded into a rigid ladder structure. Krause examined these welds with a practiced eye, looking for the characteristic flaws that indicated hurried production or inadequately trained welders. He found none. Every weld showed consistent penetration, uniform bead formation, evidence of proper heat control and technique. The welds weren't just adequate. They were exemplary, the kind of work that would earn approval from the most demanding welding inspector. In Germany, welds of this quality required certified welders, men who had completed years of apprenticeship and passed rigorous examinations. The idea that welds this good existed on every joint of what Americans considered a throwaway vehicle seemed to violate basic economic logic. The suspension system reinforced this impression of systematic over-engineering. The Jeep rode on leaf springs, simple stacks of steel leaves clamped together and mounted to the frame. This was old technology, proven technology, the kind of suspension that had existed since the earliest days of motorized vehicles. But again, the execution revealed sophistication hiding within apparent simplicity. Each leaf in the spring pack had been carefully heat-treated to achieve optimal strength and flexibility. The leaves were precisely aligned, held together with clips that showed evidence of quality manufacturing. The spring eyes, where the springs attached to the frame, rode on bronze bushings that would provide thousands of miles of service before wearing out. Nothing about these components was crude or approximate. Every element had been engineered to specific performance requirements and then manufactured to tight specifications. Weber called his team together after 3 days of systematic disassembly and analysis. They gathered in the relative cool of early evening, when the desert temperature dropped from unbearable to merely oppressive. Before them, the Jeep existed now as hundreds of separate components, each one catalogued and examined, the vehicle reduced to its constituent elements like a biology student dissecting a laboratory specimen. Weber had prepared notes, pages of measurements and observations, but he found himself struggling to articulate what they had discovered. The evidence before them challenged fundamental assumptions about American industrial capacity and engineering sophistication. He began with the most obvious observation. Every major component of the vehicle showed evidence of sophisticated manufacturing processes. The engine block was a precision casting, requiring pattern-making skills and foundry control that suggested advanced metallurgical knowledge. The transmission casing showed similar quality, with gear teeth that had been cut on precision hobbing machines and then heat-treated to achieve proper hardness. The transfer case, which distributed power between front and rear axles, contained gears that meshed with tolerances measured in thousandths of inches. The differential housings were precisely machined castings, their bearing bores held to specifications that required skilled setup and careful inspection. This level of manufacturing quality didn't happen by accident. It required sophisticated equipment, trained operators, rigorous quality control, and stable production processes. But beyond the quality of individual components, Weber noted something perhaps more significant. Every fastener on the vehicle was standardized. Every bolt, every nut, every washer conformed to uniform specifications. Thread pitches were consistent throughout the vehicle. Head styles were rationalized to minimize the variety of tools required for maintenance. This standardization represented a level of systematic thinking that impressed Weber more than any individual component quality. It suggested that someone had looked at the entire vehicle as a system, had considered not just initial manufacturing but field maintenance, repair, and parts logistics. German military vehicles, despite being produced by some of Europe's most sophisticated manufacturers, showed nothing like this level of standardization. A mechanic working on a Kübelwagen might need a dozen different wrenches to perform basic maintenance, and spare parts from different production batches might not be fully interchangeable. Richter contributed observations about the engine that deepened the mystery. The power plant produced 60 horsepower at 4,000 revolutions per minute, a modest output by contemporary standards. But this wasn't an engine designed for maximum power. It was an engine designed for reliability and maintainability. The side valve configuration meant that valve adjustments, a common maintenance requirement, could be performed without removing the cylinder head. The simple ignition system used a single coil and distributor, components that could be easily replaced in field conditions. The carburetor was a straightforward single-barrel design, uncomplicated but effective. Every aspect of the engine prioritized ease of maintenance over performance maximization. This suggested an engineering philosophy that valued system reliability over component optimization, a mature approach that could only emerge from extensive operational experience. The fuel system provided another revelation. The vehicle carried 15 gallons of gasoline in a single tank mounted at the rear. This was a modest capacity, limiting range to approximately 300 miles under ideal conditions. But the fuel system's design showed careful attention to combat requirements. The tank was positioned behind the rear axle, protecting it from frontal small arms fire. The filler neck was located on the exterior, allowing refueling without opening the vehicle's interior to enemy observation or fire. The fuel lines were steel, not rubber, preventing deterioration and improving fire resistance. Even the fuel gauge was thoughtfully designed, using a simple float mechanism that could be easily repaired with minimal tools. Nothing about the fuel system was innovative or revolutionary, but every element showed evidence of careful design optimization based on actual operational requirements. Krause's analysis of the vehicle's materials deepened their understanding of American manufacturing capabilities. The steel used throughout the vehicle was of consistently high quality, free from the impurities and inclusions that plagued German steel production as the war progressed and raw material quality declined. The aluminum components, primarily the cylinder head and various covers, showed similar quality. The bronze bushings in the suspension and steering systems were properly alloyed and heat-treated. Even the rubber components, the tires and various seals and gaskets, were manufactured from materials that showed no evidence of synthetic substitutes or quality compromises. This consistent material quality across hundreds of components suggested access to reliable supply chains and quality-controlled material production, industrial capabilities that Germany was increasingly struggling to maintain. The electrical system revealed perhaps the most sophisticated engineering in the entire vehicle. The Jeep used a 6-volt electrical system, simpler and more robust than the 12-volt systems becoming common in civilian vehicles. But within this conservative choice, the execution was remarkably advanced. The wiring harness used color-coded wires, making circuit tracing straightforward even for minimally trained mechanics. Connections used standardized terminals that could be easily disconnected and reconnected. The generator was a simple but rugged unit that would continue charging the battery under conditions that would destroy more sophisticated designs. Even the light switches were thoughtfully designed, sealed against dust and moisture, easy to operate while wearing gloves. Every element of the electrical system reflected careful attention to the practical realities of military service. But it was when Weber's team calculated the man-hours required to manufacture such a vehicle that the true significance of their findings became apparent. They estimated conservatively, assuming efficient manufacturing processes and skilled workers. The engine alone required approximately 40 hours of machining time, plus foundry time for the castings, heat treatment for various components, assembly time, and testing. The transmission and transfer case added another 30 hours of precision machining and assembly. The frame and body, despite their apparent simplicity, required substantial stamping press time, welding, and finishing. The axles, with their precision-cut gears and carefully assembled bearings, represented another 20 hours of manufacturing effort. Adding up all the major components, plus the hundreds of smaller parts and fasteners, plus final assembly and testing, Weber estimated that each Jeep represented approximately 350 to 400 man-hours of manufacturing effort. This estimate assumed modern, efficient production methods. It assumed purpose-built tooling, dedicated assembly lines, rational material flow, and trained workers. It assumed, in other words, the kind of advanced manufacturing infrastructure that Germany had spent decades building. Even with these assumptions, producing a Jeep represented a significant manufacturing investment. But the vehicle before them was not a prototype or a limited production model. The date codes stamped on various components indicated that this particular vehicle had been manufactured in June of 1942, just weeks before its capture. The serial number suggested it was one of tens of thousands produced that year alone. The implications were staggering. Weber drafted his report to Rommel over the course of 2 evenings, working by the light of a kerosene lamp in his tent while the desert night surrounded him with its vast silence. He struggled with how to convey his findings, knowing that the conclusions he was drawing would seem almost fantastical to officers focused on tactical and operational concerns. But the evidence was undeniable, and Weber owed his commander an honest assessment regardless of how unsettling that assessment might be. The report began with technical specifications, a dry recitation of measurements and observations that provided factual foundation for what would follow. Then Weber began his analysis. The Jeep represented not merely a well-designed vehicle, but evidence of manufacturing capabilities that exceeded anything Germany could currently match. The quality of components, the sophistication of manufacturing processes, and the systematic standardization throughout the vehicle all indicated an industrial infrastructure of enormous sophistication and scale. But more than this, the vehicle represented a particular philosophy of military equipment design that differed fundamentally from German approaches. German military vehicles were typically designed as specialized tools, each one optimized for specific roles. Reconnaissance vehicles prioritized speed and agility. Transport trucks emphasized cargo capacity. Command vehicles provided communication, equipment, and workspace. This specialization made sense in the context of traditional European warfare, where different formations had distinct requirements and where logistics systems could manage the complexity of varied equipment types. But specialization carried costs. It required diverse manufacturing capabilities, complicated supply chains, extensive training programs, and sophisticated maintenance organizations. Each vehicle type needed its own spare parts inventory, its own technical manuals, its own specialized mechanics. The Americans had taken a radically different approach. The Jeep was a generalist, a vehicle designed to be adequate for a wide variety of roles rather than optimal for any single application. It could serve as a reconnaissance vehicle, a light transport, a weapons platform, a command vehicle, or a utility truck. This versatility meant that a single vehicle type could satisfy multiple organizational requirements, dramatically simplifying logistics and training. A mechanic who learned to maintain Jeeps could service vehicles throughout an entire division. Spare parts could be pooled and redistributed as needed. Drivers could transfer between units without retraining. This approach sacrificed theoretical optimization for practical flexibility, and in the context of global warfare across diverse terrain and climate conditions, flexibility might be more valuable than specialization. But the most significant revelation came when Weber attempted to calculate American production capacity. The captured Jeep bore a contract number and a manufacturer's code. Through careful research using captured documents and intelligence reports, Weber's team had identified the manufacturer as Willys Overland, a relatively small American automotive company based in Toledo, Ohio. They had also discovered something that seemed impossible. Intelligence estimates suggested that Willys Overland was producing approximately 640 Jeeps per day. Per day, not per month or per year, but daily production of 640 vehicles, each one built to the specifications and quality standards that Weber's team had documented. Weber checked these figures repeatedly, certain that translation errors or intelligence failures must have corrupted the data. But multiple sources confirmed the estimates. Willys Overland's Toledo plant operated 3 shifts per day, 7 days per week, with a workforce of approximately 15,000 workers. The production line moved continuously, with a new Jeep rolling off the assembly line every 75 seconds during peak production periods. Annual production from this single factory exceeded 160,000 vehicles, and Willys Overland was not the only manufacturer. Ford Motor Company had also begun Jeep production at multiple facilities, adding another several hundred vehicles per day to total output. To provide context for these numbers, Weber included comparative data on German military vehicle production. Germany's entire truck and light vehicle industry, including manufacturers like Opel, Daimler-Benz, MAN, and Hanomag, collectively produced approximately 60,000 military vehicles per year across all categories. This total included everything from motorcycles to heavy trucks, from ambulances to specialized engineering vehicles. The entire German automotive industry, mobilized for total war and operating under optimal conditions, produced in 1 year what a single American factory produced in less than 5 months. The implications extended beyond simple production numbers. The captured Jeep showed no evidence of material shortages or manufacturing compromises. The steel was high quality. The rubber was genuine, not synthetic. The aluminum was pure. The gasoline it ran on was high octane. Every component suggested an industrial economy operating without significant resource constraints, an economy that could afford to build even its most basic military vehicles to standards that exceeded strict necessity. Germany in 1942 faced increasing material shortages, deteriorating raw material quality, and growing pressure to substitute inferior materials for optimal ones. The Germans were scraping by, making do, adapting to scarcity. The Americans were building their simplest utility vehicles with precision manufacturing and quality materials. Weber's report concluded with observations that transcended technical analysis and entered the realm of strategic assessment. The Jeep represented a visible manifestation of American industrial power, but that power was not the raw, primitive strength of abundant resources and basic manufacturing. It was sophisticated, systematic, and deeply mature. It was the power of an economy that had spent decades developing advanced manufacturing processes, training skilled workers, building industrial infrastructure, and refining production systems. It was the power of standardization, interchangeability, and mass production taken to levels that German industry, for all its vaunted engineering excellence, had never achieved. The Americans had not merely mobilized their economy for war, they had transformed warfare itself into an industrial process, applying the same principles of systematic analysis, standardization, and optimization that had built their peacetime economy. The Jeep was not an exceptional vehicle. It was an ordinary vehicle, one of hundreds of thousands, built to consistent standards by workers who would build another one tomorrow and another one the day after that. This was the true revolution, not in any particular innovation or technological breakthrough, but in the systematic application of industrial principles to military production. Weber concluded his report with a statement that he knew would trouble Rommel. Based on the evidence before them, the Americans possessed the industrial capacity to effectively bury German forces under an avalanche of material. Not superior material necessarily, but adequate material produced in quantities that rendered German advantages in training, tactical excellence, or operational sophistication increasingly irrelevant. Quality would always matter, certainly, but at some point quantity achieved its own quality. The Americans had apparently reached that point. Rommel read Weber's report in his command tent 3 days after its completion. The field marshal was a professional soldier, a man who had built his reputation on tactical brilliance, aggressive leadership, and an instinctive understanding of mobile warfare. He understood combined arms operations, armored doctrine, the interplay of firepower and maneuver. But he also understood logistics, supply chains, and the brutal mathematics of industrial warfare. He had watched German forces in North Africa struggle with inadequate supplies, worn-out vehicles, and improvised repairs. He had seen brilliant tactical victories achieve nothing because his forces lacked the fuel, ammunition, and replacement equipment to exploit success. And now, reading Weber's careful analysis, Rommel confronted a reality that his operational experience had already suggested, but that he had perhaps been reluctant to fully acknowledge. The field marshal called Weber to his headquarters that evening. They spoke for more than an hour, Rommel questioning the engineer about specific findings, probing for alternative interpretations, searching perhaps for reasons to doubt the conclusions. But Weber's evidence was systematic and thorough. Every observation was documented, every calculation explained, every conclusion supported by physical evidence from the disassembled vehicle. The Jeep had told its story, and that story confirmed Rommel's growing understanding of the strategic situation. Germany was fighting a war it could not win through military excellence alone. The Eastern Front consumed men and material in staggering quantities, a grinding attrition that showed no signs of resolution. The bombing campaign against German cities and industry was intensifying, disrupting production and diverting resources to air defense. U-boat losses in the Atlantic were increasing while shipping sinkings declined, threatening the blockade that might have strangled British resistance. And now, the Americans were deploying to multiple theaters with equipment that, while perhaps not superior in individual quality to German material, was adequate and available in quantities that Germany could not match. Rommel understood that wars were won not just on battlefields but in factories, mines, and oil fields. Victory required not just brave soldiers and brilliant commanders but steel, fuel, ammunition, and vehicles. It required the industrial capacity to replace losses, to maintain equipment, to sustain forces across vast distances and extended campaigns. Germany possessed sophisticated engineering and tactical excellence, but these advantages were finite. They could not be replicated or scaled indefinitely. American industrial capacity, on the other hand, appeared to have enormous headroom for expansion. If a single factory could produce 640 Jeeps per day, how many factories could America build? How many vehicles could those factories produce? How long before this quantitative advantage overwhelmed German qualitative superiority? These questions had no comfortable answers. Rommel forwarded Weber's report to the High Command with a cover memo that emphasized its strategic significance. He noted that while tactical victories remained possible, perhaps even probable in the near term, the long-term trajectory of the war was being determined by industrial capacity and resource availability. Germany needed to either find ways to dramatically increase its own production or seek a political settlement before American material superiority became overwhelming. Continuing the war under current conditions would lead eventually to defeat not through military failure but through industrial exhaustion. The response from Berlin was predictable and unhelpful. Rommel's memo was received, acknowledged, and apparently filed away without meaningful action. The High Command remained focused on operational planning, on the next offensive, on territorial gains and enemy casualties. Strategic industrial concerns seemed distant and abstract compared to the immediate pressures of active campaigns. There was also, perhaps, an unwillingness to confront implications that called into question the entire strategic direction of the war. Acknowledging American industrial superiority meant acknowledging that Germany's victories, however impressive tactically, might be strategically irrelevant. This was not a conclusion that the leadership was prepared to accept in 1942, when German armies still held vast territories and when final victory seemed achievable through one more offensive, one more breakthrough, one more decisive battle. But some officers understood. The report circulated through intelligence channels, reaching analysts and planners who recognized its significance. Copies were forwarded to industrial managers in Germany, men responsible for maximizing production from increasingly strained resources. These managers read Weber's technical analysis with professional appreciation, recognizing the manufacturing excellence it described, and understanding implicitly how far German industry remained from achieving comparable capabilities. Germany could build vehicles as sophisticated as the Jeep, certainly. German engineering could match or exceed American technical capabilities in almost any specific application. But building one sophisticated vehicle was different from building 100,000 sophisticated vehicles. Prototype excellence didn't translate automatically to mass production capability. The captured Jeep itself eventually made its way to Germany, shipped back for more detailed analysis at technical institutes and industrial research facilities. Engineers at Daimler-Benz examined it. Metallurgists tested its materials. Industrial efficiency experts studied its manufacturing implications. Each analysis confirmed Weber's initial findings and added additional layers of understanding. The Americans had built not just a good vehicle, but a vehicle specifically designed for mass production. The stamped body panels minimized machining requirements. The simple engine design reduced the number of precision operations. The standardized fasteners simplified assembly and maintenance. Every design choice, examined closely, revealed optimization for manufacturability, not just for performance. Some German manufacturers attempted to learn from these insights, to incorporate American production principles into their own processes. But systematic change in established industrial processes was difficult, especially during wartime when production pressures demanded immediate output rather than process improvement. Retooling required time and investment. Training workers in new methods meant temporarily reducing production. Implementing standardization across suppliers required coordination and cooperation that Germany's industrial structure, with its numerous independent manufacturers and complex subcontracting relationships, struggled to achieve. The Germans understood what needed to be done but lacked the time and resources to do it while simultaneously maintaining production of existing equipment for ongoing military operations. In North Africa, the war continued its brutal trajectory. Rommel won tactical victories, his forces demonstrating the aggressive leadership and tactical flexibility that had earned him his reputation. But increasingly these victories were Pyrrhic, achieved at costs that could not be sustained. German vehicles broke down and could not be repaired for lack of spare parts. Attacks succeeded but could not be exploited for lack of fuel. Positions were held but then abandoned when ammunition ran low. Meanwhile, Allied forces, particularly after the American entry into the theatre, showed a remarkable capacity to absorb losses and return stronger. Destroyed tanks were replaced. Casualties were reinforced. Supply shortages were temporary disruptions, not permanent constraints. The industrial power that Weber had identified in the captured Jeep manifested across the entire Allied military enterprise, from the smallest utility vehicle to the largest bomber, from individual small arms to entire armies. The pattern would repeat in every theater of the war. In the Pacific, American naval construction would eventually produce ships faster than Japanese forces could sink them. In the European Air War, Allied bomber losses, however severe, would be replaced by production that exceeded attrition. On the Eastern Front, Soviet industry, relocated beyond the Urals and supported by American material aid, would produce tanks and artillery in quantities that rendered German tactical superiority increasingly irrelevant. And everywhere, jeeps would appear, tens of thousands of them, performing every conceivable military role. their ubiquity a constant reminder of the industrial depth supporting Allied operations. The genius of the Jeep, if genius is the right word, lay not in innovation but in optimization. It was not the best vehicle for any specific role. Dedicated reconnaissance vehicles were faster, specialized transport trucks carried more, purpose-built weapons platforms were more effective. But the Jeep was adequate for all these roles, and adequacy combined with availability trumped optimization combined with scarcity. An adequate vehicle delivered tomorrow was more valuable than a perfect vehicle delivered never. This was the essential insight that American industry had grasped, and that German industry, for all its technical sophistication, had not fully internalized. The captured Jeep's story became part of the war's larger narrative of industrial warfare, a narrative that was still being written in late 1942, but whose ending was becoming increasingly predictable to those willing to see the evidence. Weber's report was one data point among many, one small piece of intelligence that contributed to a growing understanding of strategic realities. But it was a particularly clear data point, concrete and specific, backed by physical evidence that could not be dismissed or reinterpreted. The Jeep existed. Its quality was measurable. Its production numbers, while initially incredible, were verifiable through multiple intelligence sources, and its implications were undeniable. Looking back from the perspective of history, knowing how the war ended, it is tempting to see this moment as inevitable, to view the captured Jeep as a prophet of Germany's coming defeat. But in late 1942, the outcome was not yet certain. German forces held vast territories from the Atlantic to the Caucasus. U-boats still threatened Allied supply lines. The Eastern Front remained fluid, with major offensives still possible. The Americans were new to combat, their armies largely untested, their equipment unproven in large-scale operations. Many outcomes remained possible, many trajectories imaginable. But the Jeep revealed something fundamental about the nature of modern industrial warfare. Victory would come not just to the side with the best soldiers or the most brilliant generals or even the most advanced technology. Victory would come to the side that could sustain military operations indefinitely, that could replace losses, that could adapt to changing conditions, that could keep its forces supplied and equipped regardless of setbacks and casualties. This required industrial depth, the capacity to produce not just weapons but entire military systems, and to produce them continuously, reliably, in quantities sufficient to support global operations across multiple theaters. Germany had entered the war with military excellence but limited industrial depth. The strategy had been to leverage tactical and operational superiority to achieve quick, decisive victories before industrial factors became decisive. The blitzkrieg approach had worked in Poland, in France, in the Balkans, but it had failed in Russia, failed to achieve the rapid victory that would have prevented a long war of attrition. And now, as the war entered its fourth year, industrial factors were becoming paramount. The Americans, with their vast industrial capacity and systematic approach to mass production, represented a force that could not be defeated militarily, because military defeats could be absorbed and reversed through industrial replacement. The legacy of Weber's report and the insights it contained would extend beyond the immediate war. After Germany's defeat, American military equipment, including hundreds of thousands of Jeeps, would remain in service around the world. The vehicle would become iconic, a symbol of American military power and industrial capacity. But more significantly, the principles it embodied, the systematic approach to design for manufacturability, the emphasis on standardization and interchangeability, the optimization for reliability over peak performance, these principles would influence post-war industrial development globally. The Jeep became a template, not just for military vehicles, but for approaching design and manufacturing challenges systematically. In the workshop outside Tobruk, where Weber's team had conducted their analysis, nothing remained by the war's end. The temporary structures had been dismantled or destroyed. The tools had been moved or lost. The engineers had scattered to other assignments, some surviving the war, others dying in subsequent campaigns. The Jeep itself had long since vanished, either destroyed in combat, cannibalized for parts, or lost in the chaos of defeat and retreat. But the knowledge that emerged from that examination endured, documented in reports, disseminated through intelligence channels, contributing to a growing understanding that the war's outcome would be determined not on any single battlefield but in the accumulated output of factories, mines, and oil fields across entire industrial economies. For Rommel, the report confirmed what battlefield experience had already taught him. North Africa was lost, not because German forces lacked courage or skill, but because they lacked the industrial support to sustain operations against an enemy that could simply outproduce German forces. He would fight on, winning tactical victories that impressed military historians while ultimately changing nothing. His reputation as a brilliant commander would endure, but he would never escape the strategic trap that Weber's report had illuminated. Excellence could not overcome exhaustion. Quality could not defeat quantity. Industrial warfare required industrial capacity, and Germany, stretched across multiple fronts and facing enemies that collectively controlled most of the world's industrial resources, simply lacked the depth to prevail. The captured Jeep thus became more than just another piece of analyzed enemy equipment. It became a moment of recognition, a point where strategic realities became undeniable even to those who had preferred not to see them. Wars are full of such moments, when the trajectory becomes clear to those willing to look honestly at the evidence. The battle may continue for years afterward. Casualties may mount into the millions. Tactical situations may fluctuate dramatically. But the ultimate outcome has already been determined by factors beyond any commander's control, by the accumulated weight of industrial capacity, resource availability, and economic depth. The Jeep was not the cause of Germany's defeat, but it was a harbinger, a messenger carrying news of an industrial power that would prove impossible to overcome through military means alone.